5. All right, with dirty flag, I've actually got a new Rust application going up here. I'm thinking I'm actually going to make this runnable. And this might take a few like mornings of us doing this. I haven't yet like figured out a way to like give my like to move things around in the afternoon to do afternoon after work streams. But if I do, I would probably work on this a little bit more too. What I want to end up doing is just creating like a little rocket ship that flies up, and I want to attach like the engine essentially to the rocket ship and follow this pattern. Just because I want to see it like actually work and like understand that through doing. So I'm going to use GGEZ. Get the latest version here. In main, I'm going to replace this entire thing with a new snippet that I created, which just automatically builds all this stuff for me. So our crate name is Dirty Flag Rust. And then our project name is Learning Dirty Flag. And then that's it for that. We can now go and create a lib. And glib, I don't think there's anything we need to do right off the top of the bat. I haven't decided like what else I want to add into this snippet. So it's a super basic one. But theoretically, at this point, I should be able to cargo run it. Rust Analyzer, I think, was installing stuff, so we had a lock. This is the nicest part about having the new computer. Although I don't know if it's like I can call it new anymore. The desktop is building these are so much faster than when we try to do this on the notebook. All right, so here's our application. Everything is up and running, and we're good to go here. So what I want to do is create I don't need to like create anything else. We're not creating a full game. My vision for this is to have a little rocket with like the flames that come out of the bottom. And so the flames that come out of the bottom is gonna be attached to the rocket and fly with it, and then be like off and on, right? Because as soon as the let's see. Every time the rocket moves, we have to move it. And then that's the dirty flag on, right? And then it like ends, and therefore we don't care about it. We stop it. And then we don't have to draw it anymore. I think that's how we're gonna go with it. So at least that's what I'm thinking we can do with this this pattern. I'm not like, as I sort of said, I'm still like not super sure how I want to like how this could work. But it sounds like we're gonna have these two classes, structs, graph node and transform. So if I just do these in here, so if we have a struct transform, and it sounds like this is like what we figured out at the very end of yesterday was this is gonna hold like the locations, like our location. So we're gonna have a location, and that's gonna be an algebra points 2. So you're gonna be a 0.2 of F32. And is there anything else that we really need to care about? Right now, it's just like the location. And then we're going to implement on transform pub function. And so here's where we have origin. So instead of new, we have an origin. An origin, we don't take in anything. We're going to return a transform. So transform. Oh, I wanted to turn off. I want to experiment. If I leave the game up but make it smaller in the corner, like down there. I don't know if this is as annoying or not, or even like how visible that is. So anyways, let me know if how you all feel about that, or I can still turn it off. Okay, so I have transform, and we're just gonna have a location, which is gonna be a brand new point 2, which is a new, and we're gonna seed it with 0.0 and 0.0. And that's it. Now we're also gonna have this combine method. So public function combine that takes mute self, and it takes an other, which is a transform. Specifically, I think this has to be a reference to another transform. And we're not going to return anything. Instead here, this is where we're going to update the locations. And so they said earlier that the transform is going to do a matrix, the matrix math, like yeah, so like theoretically we'd have to go figure out how this works somewhere else. The idea is that if I have a rocket and I have like a engine attached to it, and then the rocket is the main thing, so it moves, the engine has to move with it. So this combine is that engine moving with it. And so that's the location. It's offset already. It just needs to move by whatever the other point moved with. And maybe that's add. Like maybe I can just get away with adding. So self.location .x plus equals other.location.x. Location.y plus equals other.location.y. Okay. So we'll see if this ends up working later. And then the other thing we have here is a struct graph node. And we're calling this, but this looks like it's our game object as well. So in here, we're going to store a mesh. So we have graphics. I'm going to store a mesh. We're also going to store a local, which is a transform. Okay, so then we have a local, which is a type transform. And we have children, which is going to be a, right now, let's just do a vector of children. The children are graph nodes. So it's a graph node. And I think that's it for us here. So let's do implement on graph node, hub function new. So when we create a new one, we were going to take in a mesh, which is a type mesh. And we're going to return a new graph node. And let's see. Okay, so we're going to return graph node. Obviously, the mesh gets stored here. A local is a transform. So the local is just creating a new one. So local is a transform origin, like that. And then children is an empty array to begin with. So it's a vec like that. And we're going to create a scene graph to begin with. And so the scene graph doesn't have a mesh. Well, if I don't have a mesh, I can't really do this. Because like there's no such thing as null in Rust. So this is going to have to be an option, which then inside of it has a mesh. So this is an option mesh. All right, so that's easy to just store in what I get in here. So that the mesh is either going to be none or it's going to be some with a mesh. And then graph node. Okay, so then we're creating the graph. Okay, so we're going to have a scene graph, and we can do that up here. So when we create our game state, we need to store our scene graph node. So here, let's do this. Scene graph is a type graph node. And we can do scene graph is a graph node new, and I'm going to pass in a none. So no mesh. Okay. Then we're going to have render mesh. So in order to render a scene graph, all we need to do is traverse that tree of nodes starting at root and call the following function. Okay, so then we're going to have a render mesh inside of here. Which is going to take reference to self. It's going to take mesh and transform. We won't implement this here, but if we did, it would do whatever the magic renderer wants to do. Oh, is this not? Oh, this wouldn't be part of graph node. This would be like another function somewhere else. So getting this, okay, so if we have another function, so let's just down here, let's say we have a function render mesh. We're going to take in a mesh. We're going to take in a transform, which is a reference to a transform. They have like the real transform and then a reference to the mesh here. Which that's interesting. It does make sense. Like the mesh, I don't need to give ownership of the mesh. I don't really think I need to give ownership of the transform. However, I also need access to context. So I do need the context, which is mutable context. And we're going to return a game result, which is that. So rendering the mesh, it's going to be graphics, draw, pass into context. The drawable is going to be this mesh, and then the params are going to be draw. Do I not have draw params in here? No. Graphics, draw param, draw param, and right now we only have this this location off of the transform. So we'll do draw param new, and then dot destination, and then this is going to be the transform dot location. So this is where we're going to move it to, and then we're just that's the return. It returns the game result from draw. Okay, so then we have render mesh. Now we have to have access to context to make this work. So we'll see about that when we get to it. Okay, an unoptimized traversal first. So in graph node render, we're going to take in the parent world. Which is a transform. Now it has us taking ownership of that. I don't know if that's a good idea. I think there's going to have to be a reference to it. Transform world. Okay, so we're not going to return anything. We're going to, so let world equals. Now take in our local. So this needs to be mutable here. So self.local.combine, and then the parent world. Okay, so if we have a mesh, so if we do have a mesh for ourselves, okay, so if let sum, it's gonna be a mesh equals self.mesh. All right, so now we have the mesh if we have one. We're gonna call render mesh, pass it the mesh, and then the world. Problem, we need the context. So not just render here, but we also need context available here. In order to do that. So here is render mesh. We're gonna pass it a reference to the mesh. The transform is gonna be our world. So reference to world. Right, because we need this, we need the world multiple times. We can't give ownership away. And then context. Now I can question mark this, and in doing so, this render is going to have to return a game object, or a game result. Like that. All right, so that's only in the left, so it's letting me know that there's a chance I might not return game result so far. Okay, so that handles the if we have a mesh. Then we're going to loop through all the children and have them render as well. So for child in, I need to do this as mutable. So this needs to be a mutable reference to self.children. And then I need to so for each child, call render. So child.render. The parent world is just the world, so it's a reference to world. And then the context is this mutable context, so I can just do that there. And then render returns, so I can just do semicolon like that, or a question mark like that. And then finally, at the end of this, if we reach the end, we have this okay that we return. Now, expected struct transform found nothing. So this is the parent world, is this world right here. Self.local, okay, so self.local.combine returns a transform. Okay, I missed that. So combine returns a transform. So in this case, are we taking ownership of the transform and then not mutating it necessarily, but like creating a new one? Let me see. So we have so self.local combined with the parent world. I want the local to be updated without taking the parent. So in a way, I want this to be a mute self. We take ownership of self, and then we return self. And that gives us this world here. Now, what are you upset about? Cannot move out of self.local, which is behind immutable reference. Oh, I can't actually get rid of this local. Okay, so I wonder if instead I should do this and leave it what I had before. We just do this and it's a mutator. Meaning up here we're not going to take in. We're going to take in a mutable reference to self. We're not going to return self like that. And we're not going to return a transform. We're just going to mutate. Okay, what's next? World. Cannot find value world in the scope. Right, because now self.local is our world. So this is going to be a reference to self.local. And you are going to be a reference to self.local. Self.mesh. Cannot move out of self.mesh, which is behind a mutable reference. I don't want to move you out of a mutable reference. Can I? So I don't want to move you. I just need to get a reference to you. Can I do that? Yeah, I can. Okay. No errors. So now I have that going. Now if I want to create our like scene graph, we have that. And now if I want to create another one and attach it to this scene graph. So specifically, let's say I want to do let sort of like rocket body equals, it's going to be graph node new. And then it's going to be our option. So we need to in mesh, a mesh builder. And we'll also do rect. So let rocket body mesh equals mesh builder new. Okay. Dot a rectangle draw modes. Okay, so we're gonna have a draw mode fill. Our bounds is gonna be a new rect. So this is gonna be a rect new, and then we give it the X and the Y, and this is gonna be relative to the scene graph. So if the scene graph is this entire window, or the entire window that we have, which is like something like that, I want to be like over by some amount. So let's say we have I don't know, like 150.0. The y would be something like 300.0. I'm not exactly sure what the size of that is yet. The width, let's make this 10.0, and the height is like 50.0. And then color. I'm okay with making this white for right now. I don't really need to make a super big like set of colors for this. Okay, so that gives us our rect. Rect new returns the rect body. And then after that, we can build this, which means we need context. And then we need to semicolon that to store. So in new here, context, which is a mute context. And instead of game state, I'm going to return a game result, which has game state. And then over here, we're going to return OK. Okay, like that. Okay, so rocket body, graph node new, and then our mesh, which is going to be a sum rocket body mesh. Like that. And then in here, we're going to have our rocket. Oh, I didn't put it in here. Rocket body is a graph node. Oh, how do I add it in? It's not a child. I don't put it in there. I don't add it in there. I add it to as a child to graph node. That's all I end up doing. So this may need to be mutable, so then I can push a child in. It's not there. Wait, pub. That's what I want. So I'm not putting in there. I'm not putting you in there. I do need scene graph to be outside of here. So that mute scene graph equals, and then we're going to do scene graph dot children dot push rocket body. And then in OK game state, our scene graph. And then to get it all to work, just to see whether or not any of this works, we are going to call the render on graph node. So here in draw, we're going to do self dot, let's see, self dot scene graph dot render. Parent world. What would the parent world be for this? Because there's nothing, right? So it has to be an empty transform. So we have to create a brand new transform. So that's going to be transform origin, like that. And then the context. And you want it to be a reference to an empty transform. So we would need to do something like this. Actually, I can pass a reference in, can I? I can just do that. 5 errors. This function, oh, right. We need to pass in the context. So the mutable context. That. So that makes you happy. What's next? The trait bound result. Oh, right. Game state. So when we're getting the game state out of this, we need to dot unwrap it. And you are unhappy. Cannot borrow context is mutable. It is not declared as mutable. Okay, so context is a mute context right there. Equals mute match. Hey, aren't I doing that? Maybe right here you need to be mute. I can swear that I'm... Okay, so that's not happy. So we get... Okay, that's... Chantilly, good morning! It's going okay so far, I suppose. We haven't had a chance to test our code yet, which is what we're trying to do right now. Okay, so context. Are you actually mute context? You are. Wait a second. Can I just pass it in like that? Oh, I can, because I already have it as mute context. What's the red dot? I made the drop game really small, and so that down there is like the drop game, so it's still playable. No errors. Let's see if this runs at all. Okay, this ran. We have our rocket body. And the rocket body is attached to the scene. It's a mini version drop game. Yeah, exactly. Okay, so now I want to create a little bit of flame out of here. And so that's going to be on the rocket. So attached to the rocket is the flame. So in our main library here, we have to create another one of these. So we have the rocket body mesh. Let's create another mesh here. So this is going to be the flame mesh equals a mesh builder new. And then dot, if I can create a triangle, that would be perfect. I have triangles and I have 2 triangles. That's it. That's all I've got. What else can I build? Circle, polygon, line, rectangle. Okay, so if I do triangles, all right, so this wants a reference to an array of points. Okay, so here's the way that's going to work. We're going to have a reference, and then the different points. So I'm going to put this on different lines here, just to make it a little bit easier for me to see. So it's an array of triangles. The length of the list must be a multiple of 3. Okay. So then in here, we're going to have points. So point 2, new. And this needs to be, if I put this at 0, we want it to be relative. Let's put this as 0 first. Let's just set this. So I'll do the top of the, we want it to be upside down, right? So like there, like that, something like that. So 0, 0, and then move over. Yes, maybe I want 0 in the middle. So I want like negative, what's our width of our body? It's 10. So negative 5, negative 5.0, And then a y is 0.0. 0.2 new. And then we're going to have 10.0, 0.0. And then a 0.2 new. And then we're going to have halfway in between. So it's going to be 0.0. And let's just do 10.0. And so that gives us these triangles. And then our color, we want you to be red. So let's create a color. All right, color new. We're going to have a 1.0 for our red, and then absolutely nothing for everything else, except alpha. That's 1.0. Then we're going to build. What's wrong with this? That's triangles. Triangles returns, a game result. So we have to do a question mark. Then we can do a build, pass it into context, another question mark, and then a semicolon. And that gives us our flame mesh. So now we can we have a rocket body. Now we need let rocket flames equals, or maybe we'll call this rocket engine, equals a graph node new sum flame mesh. Now, in a rocket body, you need to be mutable, so that way afterwards, I can say rocket body dot children dot push rocket engine. Does this give me the rocket engine just for free now? Or I guess not for free. I just wrote a bunch of code for it. Is it now on there? It is. Okay, now the problem is it's up here. It's not it's relative to the scene graph. But I wanted it to be relative to this here. So that's a problem. I need the location. I wanted it to be up in like the top left corner of this the rocket here. So when I do my transform, what if I do... The other thing I was thinking about was multiplication equals, but like there's zeros, so then it becomes 0. I'm not sure if this is the right way to do it. Let's try it. It's like, this is the my biggest nemesis, math. Yeah, okay, because multiplying by 0 makes it 0. It doesn't really help here. So if I want my transform to move this over and say like, hey, you're attached to this rocket body. You don't know where you are. Like, you don't know where the rocket body is, and you don't care where the rocket body is. But when we run that render, we want to update your location. So that way you're just over here. Or, I guess, over here to begin with. I guess, do I have to, like, care about it when I first create it? So do I have to be aware of its location here? And say, okay, your position needs to be translated because I need to say rocket engine, I attach you to here, and I need you to be moved to essentially here, this location. You're kind of good at math. All right, so here's where my rocket is. How am I, and the book doesn't seem to cover this, is how to make sure their locations are correct. Like where do we reset, like set these to begin with? We're gonna have our mesh. We have our local, that's just a transform of origin. That's a question. Should local always be a transform of origin? Should it be a clone of the transform that it's the parent's transform? That would almost make sense to me. If it's a clone of the parent's transform, then I get its location as like the base point, and then I like go from there. If I do that, I can't, because the graph node is not aware of it being a child. Now the rocket engine isn't at 0, 0. Wait a second, even though I'm at, even though I'm doing that multiplication math, it's not moving the rocket over, is it? Because the mesh is right there. Okay. So the triangle should be really set to 0, 0. So we should really be doing this at 0, 0, 0, 0. And then we're gonna have the same problem, which is not a bad thing. We're all over there. And so now they are attached to each other and they're moving. So I need to figure out a way, if I can get the rocket body to move down, and like whatever system that works, does that have our rocket engine move with it? So we need to have an update now. Now we only have access to the scene graph. So we need to call update, which then would go through each of these and update them as well. So what would that look like? So pub function update, which takes a mutable reference to self. Let's say I just want to like move everything to, you know, down and to the right. I don't want to move the scene, right? I only want to move the rocket. I only want to move the rocket. I don't want to move like the parent scene. How would I? Am I giving a reference? Hold on. So children is pointers to children. Isn't the transform as defined here supposed to be the origin point of the node and the translation, rotation, etc. from that origin? You then transfer the graph to apply the parent transforms to the origin to place everything relatively. I think so. I think you're right, Utsby. But now how do I update them? So the transform as defined here is supposed to be the origin point of the node, which is, that's what I have. So it's like it's starting at origin 0, 0. Which is, you know, the top left of the screen. We traverse the graph, and we apply these transforms over to it. And then they get placed relative to each other. However, they're relative, the meshes don't really know where they're going. So I have these dests that are happening. It's like the destination to the transform location. So if I want to update it, we move, we update the location left and right. So am I like combining two different ideas together here? Should I really be having like a game element, like a I guess not a game element, but like a struct game object, which would have its location, which would be a .2 f32, and so it has its location, but this location is just where it thinks itself is, and then there's a transform that moves that relative, and then I store this game object in here. And so if I do that, if I have like basically a location, if I have the location in the mesh, and then I draw it, like has it draw itself, will render itself. The rendering is happening here. What's interesting, okay, so this is just rendering, right? We're not affecting the actual location of, we're supposedly not affecting the location of the thing, the game object, as it were. As the rocket moves, the game engine needs to move with it, but it has its own thing. Like maybe it's like growing and shrinking, like oscillating, as it were. And so if a graph node was holding a game object, and then children, which were game objects, well, I guess they'd be graph nodes that held game objects. Do they need to be outside, like on their own? I think they might need to be. Hold on, let me not do that. So we have this rocket ship. If I do a sort of rocket body, which is a graph node, we store the rocket body here. Did I give ownership of it away? I did. Let's just say we're taking in a reference here. So children is going to be a vector of a reference. We're going to have the lifetimes, aren't we? Expected name lifetime parameter. Oh yeah, that's a problem. Because as soon as I start doing lifetimes here, why is the drop game super small? Oh, I was just trying to make it like not be in the way of like the full code. What do you all feel? Like do you feel that I should have not at all, full size, or like different position or something? Also, good morning. It's a visual test. Okay, so if I can't have access to graph node here. Ownership. I wonder if this pattern isn't like I have to rethink this pattern completely for Rust because like the entire pointers thing. Or I have to use a game engine that won't like just screw me over with lifetimes. Because if I start having to do lifetimes, with GGEZ at least, then they need lifetimes everywhere, and it becomes just this nightmare. Render. If I have update in here, then we go through the children and we update them. Okay, so let's say we have a pub function update. We don't return anything. We're going to call update on ourself, and then we call update on the children. What do we want to do for ourselves? We don't want to do anything for ourselves because we have to know what we are. No. Maybe on a corner. Thought it was lifting line. Oh, I could try a corner. I could try it down there. You could try that. There's a bunch of different corners I could try. Ooh, not that one. We could try upper right corner. On your face, and we should aim for my nose. We could try right above me. There. I guess like the problem is I don't know what I should be doing for this. And I wonder if this comes down to like holding in the graph node the update like some function like we can inject in. And then graph node becomes a dynamic dispatch graph. Okay. So if we call update, we then need to call like whatever custom update that we have for this. And implement that? Is that right? And I need to store it internally. Oh, right. That's what it would be. I would have to do graph node like another struct that holds the update function. So like custom update, something like this, which is going to be a right now we can just do like maybe an option that holds a function or a struct, but then we can pass it. Okay, then we pass in what this is. So we're gonna have like a trait that holds the dynamic dispatch of what we pass in. So if I have like a trait of update, I think it's update like that. Function. I don't want update specifically on here. Maybe I do. Update, you are mute self. I don't know if we need to do context. I don't know if we're going to return anything, so I think it just might be something like that. And then we're going to do a struct, and we're going to have a Okay, so we have a scene update, which doesn't do anything here. And then we want to implement update for scene update. This gives us function. Okay, then we have update, mute self, and we don't implement this. And then we're gonna have a struct. So we need rocket update. Impl update for rocket update. Update. Okay, so this takes in a mute self. And we also need to, oh, can we not take in anything else? It's not this. We don't impl update for rocket update. Oh no, we do. Oh. We need to do this against graph node. We need to have like specific graph nodes for different types. So we have like a generic graph node like this. How do I do this? If I have an update, then we're gonna have to pass in the graph node. That's what I do then. Okay, so then this takes in the graph node too. So this is the graph node, which takes in a mutable reference to a graph node. I need to actually do this up here. Okay, mutable reference to a graph node. That makes you happy here, and then you need to be updated. Okay, so now I can update you. So for the rocket update, we are going to go into graph node dot local is the transform. So local dot location and update you. So location dot x plus equals like 5.0, let's just say. Or maybe 1.0 graph node dot local dot location dot y plus equals 1.0. So that's down and to the right. You are not being used, that's fine. Now we want to store the update as a struct inside of graph node. So here we're going to have the update, which is a box, which is a dyn update. Then inside of graph node, okay, so new one, we have to create an update, so we have to pass that in. So we're gonna have a box dyn updates like that, and just pass that on through. So update. And then here in, we're gonna have a pub function update, which takes a mutable reference to self. And then we're gonna do self.update and call it. Wait, can't be update. So run update. Maybe we'll just call it run. Self.update and run this. What are you upset about? No method name update for mutable reference graph node. So I have graph node update right here. Oh, because it's update.update, isn't it? Because it's going to be, okay. Update.update. And then the graph node, so that's going to be mutable reference to self. Okay. I don't know if this is going to work. There's a lot of code. This function takes 2 arguments. Okay, so now when we create the rocket engine, we now need to also create this special update function for each of these. So this graph node needs to now have the update, which is a box dyn update. So with some mesh, and then we're going to have a box new, and then the update. So rocket engine is a rocket update, which is like that. So it gives us a new one of those. Rocket body. Oh wait, rocket engine doesn't get anything at all. I need a new sort of like empty update. Struct rocket engine update. That pull update for rocket engine update. Update, we just do that, and we just don't implement you. So that's rocket engine update. So rocket engine update. Then here in rocket body, do a box new rocket update. And then scene graph. So we have a, I mean, I guess we could have like an empty update too. We have trait update. Oh, we have a scene update already. That was smart. So we have a none here, and then we're gonna do a box new scene update like that. More code means progress, right? Yeah, absolutely. Okay, so we do all of that stuff. What are you upset about now? Use a moved body, rocket body. Okay, so rocket body got moved. Where? When? Rocket body mesh. Look at that. Ooh. I push rocket body into there. I don't need rocket body here anymore. We're good to go. Which means I don't need you here. Our update is going to be happening through the entire scene of everything. All right, what's next? Error-wise. Cannot borrow self.update mutable more than once at a time. Oh no. Okay, so mutable self, update the graph, and then we pass in self. Let's see, it needs to be a graph node, but this is the graph node. Let's see. Right, that's a problem there. Right, self.update.update graph node self. So this is a problem. We need to run this method, which then mutates itself, or at least this one does. And it mutates the graph node to get the graph node of itself. I have this transform. Local transform. Okay, hold on. Can I make you hub? Hold on. I know you're upset. instead of graph node, what if I passed in the transform itself? Would that even work at all? Or would we just still be screwed with this? So if I just did the transform, and we have this mutable reference to graph node. If I did a mutable reference to a transform, so transform and then just straight up location like that. Now up here, we don't want self. I want self dot local. But I think we're going to run into the same problem here. Expected mutable transform, found transform. So still going to say we can't. Oh, okay, never mind. We're running. Okay, so then run here is working. So this updates myself. I want to do the same thing we have in render here. We render ourselves, and then if we have any children, we loop through all of our children and we run that too. This was fine because we were not mutating, but now we are. Wait a second. This might be fine. Let's try it. So essentially I want to do this. For child in the children, we want to run on the children, and we want to pass in mute self. Oh, that's a problem. Just nothing at all. Like that. Okay, you're not upset. So we're gonna go through all the children run on it now. So that means in our update here, we're gonna do self.scenegraph.run. Okay, no errors, no warnings. What's the chance that this weren't running? I wish I had like I need something up there so it'd be like, oh, what's the chance? And like we get like a bunch of thumbs up or thumbs downs that like, you know, have a big yeah, like it works or it doesn't work, and then like, you know, a big graph, and then reward people for if it does or doesn't work. All right, let's run it. I mean, so it ran. I don't think it's doing anything. So here's our rocket body. It doesn't seem to be moving at all. So in our graph node for render, oh, wait, I want to take this away from multiplication equals back to plus equals. Try that again. Okay. All right. So I got the body to move, but the engine didn't stick with the body. I mean, it kind of did. Did you notice that? The engine is moving at an accelerated pace to the body. So is this where the flag comes in? The engine isn't moving. Whereas the body is. So I need to have a dirty flag on one of these, and every time we move, we update the engine? Okay, so when we do a transform, okay, we do like plus, minus, that updates our location properly. In our graph node, we need to know if we're dirty. Looks like you're keeping a position update across frames. Keeping them like, well, yeah, they're saving, right? Or am I not understanding? I want the body to move. I want it to update the move for the children. For our rocket, we're getting a rocket update for the rocket body, and we're getting a rocket engine update for the rocket engine. The rocket engine doesn't do anything, so it's not actually moving. So what that means, I don't want this combine to actually do anything when the rocket engine isn't moving. But even if it did move, I want it to like move left and right. The engine transform offset shouldn't record its world position as calculated in combine. Okay, so the engine transform offset should not record its world position as calculated in combine. Hold on, let's see. Does that mean I need 2 locations? I need the world location and I need the local location? Right now I only have 1 location. So if I have like a world location and a local location, then here in graph node, I would have a location as well, wouldn't I? So this would be a point 2, F32, like that. When I create the new graph node, let's say you need to be not that location point 2, F32. Okay, so this is your local location. Right, you need to be like the actual point 2. So you are new, and we start you at 0.0, 0.0. So when I do update, I'm not updating. So I don't want to take a transform. I want to take in the location of where I am. So that is the self. That's the graph node. Which is the problem, isn't it? Because I can't pass that in mutably twice. Can I pass in the position? If your render is currently doing a complete traverse, then the combine should only be creating the transform to pass to the children and to render your mesh. I think that's what's happening, right? Let's see. So here in render, we're combining which is mutating. I wonder if that's a problem. Because I don't want to mutate. That update, that like actually changes its location. Because I want, what happens to world at the end here? So we get world, and we just pass it around. So we're creating a copy essentially of world. So maybe the first thing we do is we do let world equals self.local.clone. So we clone world, and then we can do, we need this to be mutable. Then we can do world.combine. And then we go with that. And then here it's going to be a reference to world.local, reference to world.local, like that. Okay, so this is saying that a transform doesn't implement clone or copy. Let's fix that. Derive, clone, copy. 10 errors, yay! Okay, so no field, local, and transform. Right, because we wouldn't have it there. So, like that. Method update has one, okay, yeah, then we need to figure out our update. This is a completely different issue here. I want a local location. The code local is changing permanently every frame, so your engine offset keeps accumulating the world position right. I only want to update. Okay, so if I put this back, so transform your mutable transform. All right. There we go. Utsby, thank you for the help with that. We are moving our rocket, and our engine is staying with the rocket. So we've attached the engine to the rocket. Oh, that is so cool. So this isn't the dirty flag part. We've just figured out how to attach things to each other if we like, you know, wanted to do something like that. Programming Mouse, good morning. I could like figure out some ways, like have it go back and forth. We could also have, like, for a rocket engine update, I could be having it move up and down. I think that's what I could be doing. I could be saying, I want the transform to move like down, then move up, or do something that would like shrink and go down. Or let's say that I want it to every 10 frames change direction. I don't actually have time to like do anything like this. I think I'm gonna want to do an update here. So like have rocket, have engine move up and down based on, just like based on time. So it's like going like that, maybe slightly, or it's like changing, you know, growing bigger and smaller or something like that. And that allows it can do that because we are it's like its own location is separate, and I've attached itself to the rocket, and so if I move it relative to it, it should be fine. Interesting. Okay, this is pretty cool. And so what I feel like, we haven't gotten to the dirty part yet. We're just rendering every single time. What I envision is creating the rocket, maybe creating a couple of these, having the rocket be on, like everything be in an off state, and then after like X number of seconds, flip the dirty bit, like then say, okay, now go time. We move it up, and then the rocket engine turns off, and then the rocket still comes up and then falls back down again. That's all I want to do. And I think that will be like the dirty bit will be for like applied at different times for different pieces of our rocket. Maybe I should do a boat. I don't know. Oh, maybe I should do the drop game because I could see down. Where's my mouse? It's not showing on my OBS. Down here, I think. Can you actually see my mouse? I feel like I'm not capturing my mouse properly. It is... Oh, interesting. Every once in a while I see it, but then I don't see it again. I don't know why. Okay. Down like right there. Those boxes, as soon as they hit there, they become like off. I could do a rocket landing on a boat. Yeah, that could be cool. Maybe we'll do like a long like stream on Saturday or something to sort of like play around with this more, see what we can get. For right now, I think we're like pretty good with this. I don't know if I want to like tomorrow continue on with this again, but this is a pretty cool sort of like a scene to attach things to. I guess we still have the dirty bit, so I might want to do like the dirty bit update for this one continuing tomorrow. I think that's going to be the plan. Anyways, thank you everybody for stopping by and doing this. I'm going to make the stack game back to full size again. What is that? F, Command F. There we go. You can have the boat moving. Yeah, there's all sorts of things I could do. We could remake the stack game, but I'm not going to do that tomorrow. I think tomorrow we're going to add in the dirty bit to this implementation, and then we're going to call that